everybody. Thank you for having us. I'm a creative director from GFI. As you saw on the what was it on the program, I was supposed to be here with Martin Koiš and Radoslav Vuklović. Martin Koiš was lead designer of this building of Eurovea Tower, and Radoslav Vuklović, he is head manager of GFI, of our studio, so he is responsible for most of the slides you will see. This week, I don't know whether you have noticed or not, this week was official opening of this first skyscraper of Slovakia, Eurovea Tower, and that's why we wanted to use this opportunity to kind of look back to time, what we went through and how we used these digital tools to blend into this not only creative process, but into this building process. Because in the building process, you are dealing with many manufacturers, many contractors, many professionals who don't use BIM software, parametric software, which we wanted to use. We had to find ways how in that time motivate our collaborators, and how to find ways how if we were not successful and we didn't find ways how to pursue them to use these advanced tools, how to make it approachable and usable for them. So our presentation will be about kind of working environment we went through, and how we build it up so we can produce the documentation and control the building process with BIM software, Revit. Revit is, as you can see, is in the center of the process, and how we can connect our creative part of architects who were using mostly SketchUp, Rhinoceros with Grasshopper. And of course, we have many colleagues which prefer to use AutoCAD, and all these creative and designing parts from different architects who wanted to be part of. We wanted them to be part to collaborate, and so we had to find a way how to incorporate it through Dynamo, and then actually you can see we started to use Dalux very heavily, and exports to Power BI and WAC. I think that's for the WAC. Okay. This is 2015 when there was a competition for this site, so I just quickly go through our proposal, which we amazingly won, or amazingly got commissioned to design it and to build it, or help to build it. Those are some initial massing which were based on the competition proposal. We had in our mind to create the third triangle. We knew that Panorama City, they were like 150 meter tall towers. They got smaller just because of crisis, so we already had kind of height benchmark, so we knew that we can have a high tower there. We just shifted it more towards the Danube. Then we went through the finding kind of best or more best shape for the tower, and we ended up with current design, what you know, using grasshopper and rhinoceros. We use this grasshopper also for testing design ideas of many particular design problems, and also for finding parametric bits and pieces to the tower, which although it looks very kind of simple, it has many kind of different shapes that we need to control with these parametric tools. At this point, I would kind of end this part of the process, of the designing process, which end up in the form we all know. And this is those are the images that are very similar to what has actually being built. And we wanted to speak about that process that I already mentioned. How to produce drawings and how to control the building process with BIM software, with the Revit. I'm showing this example of Sky Park. This is our kind of first big project that we used Revit for, and at this project we set it up many processes. We found many kind of many solutions, because in reality you have some BIM software like Revit, but it gives you only a certain amount of possibilities. You will always have to find kind of tweaks, how to customize it to your needs. This is, for example, we are showing this image because Revit really, at that time when we were doing documentation for Sky Park, was not able to deal with this even optimized geometry of exoskeleton. So at this project we had to use geometry for geometry optimization Rhino, and then find a way how to incorporate it in Revit. And in Revit we were kind of checking all the documentation clashes and kind of buildability of whole things. And this is the image of the mock-up. This is you can see a balustrade which luckily ended up in glass, but in the process you can see that you have all elements modeled in 3D. So I come back to the Sky Park, which is the main topic, and just quickly, it's been a very big project. It's not, it hasn't been just about Sky Park Tower, but about whole mixed-use complex of residential buildings, commercial buildings, and offices. And so we had to find a way how to divide it and how to divide it into many different groups of people or teams. And so you can see these image show that you have different different files, and at the file you can see who is the head leader of this part of the project, who is responsible for what. And this was kind of, at this project we went through very kind of painful learning curve, how to teach all the teams, how to not look only on their part, but how to get informed what's going on the adjacent building block. So actually, this is something really what we find out, how difficult it is to kind of incorporate these processes, so people know where to look for the information, where to check if something is not updated what they are working on at their file. With this project we found out very big help with Dalux, if you know the software. It's online representation, or like one-to-one representation of a BIM model, which can be also split into different small files, which can be then sent to particular team members who are responsible for that part. You can see it's split in there according to the objects, and objects can be split according to the structural part or facade, and according different filters. For example, filter for HVAC or MEP. This is like obligatory images to show like, from last decade. I think we had to show it as well. So because actually, as I said at the beginning, this project started 10 years ago. So it was, and I have to mention again that the biggest challenge at the beginning was to find consultants who would use it, because for the years before we had some consultant, we had good relationship with many of them. We believed in their expertise, but many of them actually were not willing to start to collaborate with us on this software. So that's actually that was the state of the kind of milieu, of this our milieu at that time. So we took two different approaches from beginning. Actually, I think, correct me if I'm wrong, but many crucial consultants, we were kind of remodeling it into in our software, which was very painful. But then we found or pursued, for example, HVAC consultant to buy the software, which wasn't very easy decision for them to buy it and to learn it, and it helped us a lot. So it's this is the same kind of same principles. You can see this image is important because in terms or here what I only want to say here is that the model was the core of the this B model is a structural file or file of structural engineers. All others, consultants or professions, they were kind of built around this structural model. Structural model. This is also an example of the thing that you can see. Clean structural model with the facade and detail of it. And if you wanted, you can also kind of open the model of reinforcement. This is also other very I would say, part of our learning curve, that the project was so big that we find out that at some point it took half an hour to 40 minutes just to open it for somebody who were not very disciplined to work it like it was supposed to be worked with. So you will see later that we had to develop many like custom tools which are not on top of the Revit, but I would say were beside the Revit. They that helped us to kind of maintain the grip of the complexity of the whole thing. One of the tools was actually here I'm missing. It's so one of the tool was Dynamo. For those of you who knows Revit, you know that Dynamo is a tool that is similar to Grasshopper. It's a similar concept. And this is just one of the example. We had to build Dynamo tool to at the point if we were kind of drawing parking spaces, and if we want to recount them or not recount them, also recount them, but give them actual numbering, that this tool, you run the tool and it would go through the whole models and give correct numbers, and at the end you can see how many car spaces you have and in what times at which places. You can imagine how difficult it would be without this kind of tool, the tool that is not building in Revit, but if we would want to do it without this tool, we would have at a certain time do it again and again, and it would be just unmanageable, because it would also create many mistakes and problems. This is the other tool. It's a very interesting one, but it will be more interesting when I explain it. As I said, the model is the center is structural model, and then like WAC construct, fire engineers, and everybody were designing their parts. And when we put it together, then these models go through all those through pipes, and the tool was looking for the clashes through the walls, and when it found clash, then it checked what kind of pipe is, whether it's a fire engineer pipe or it's a WAC pipe, and according of that it created the opening, and not only created the physical opening in that 3D model of the structural model, but also put the correct specification of that opening, which is very important for documentation, and correct properties of the opening, because it's different which openings you are kind of creating or using. This is just example of other kind of workflow, because everything was designed in Rhino. Also, everything was designed in the Rhino, but at a certain point was kind of was easier to redefine it with Dynamo again in Revit. We had this model in Rhinoceros before, but it was better not just to import it as a geometry, but to kind of redefine the definition again, and with that we can have more parameters of each element. This image just show what kind of complexity we were able to maintain and maintain control of with this tool. That we have one floor plan on our layout, and out of that layout we were able to create different apartments and documentation for all apartments. This part is showing the things that I started my presentation with. Is the problem that we were dealing with, or are still dealing with, how to incorporate our collaborators who cannot use the software because the software is very expensive. It's and it doesn't make sense, for example, for collaborators from door manufacturers to buy it. And so this example shows the usual way how you deal with it. You have some specification in Revit, you transfer it to the a simple text file to Excel, and then you create this Excel sheet, and it's very kind of manually demanding process, and also it can create many mistakes. The other kind of process we find with throughout the time was this image shows how do you say, the schedule of all the doors we have. There are many more, I think around 3,000 or something like that, 4. And we had certain parameters which were kind of optimal to specify in Revit, but there are much more parameters which are better to be specified by contractor, for example, Albo or I don't know which contractor. So we created this Excel sheet out of the Revit, send it to contractor, and they fill it up the specification, and then we had the tool to bring it back to the Revit. So we had better, richer file with more information, so we could also give a client better understanding of what's going on. And this is the, I think, most advanced process of sharing this information with third party. We have right now, we have custom RevitPy RevitPy tools, PyRevit tools, sorry, which at every opening of the file at a certain time every day collects certain information from whole models, and then we can analyze it better through software like Power BI. You can see. So this is the Power BI software, which is not a Revit tool, but data is automatically exported from Revit, and then we can use it kind of in Excel sheet way, which is very kind of intuitive for many people, but it's much more advanced, like it's a database, and so the informations are interconnected, interrelated. So this proved for us to be very effective. And this is also kind of a very important tool. What we are using is to control how to have the way how to control what's going on with our files, because we have I didn't say, but we are a company around 60 people, and when we were doing this project, it was around 100 people. So you have many people working on many files, and you had to find a way how to control it. And just like I said, by exporting at every opening of the file and every closing of the file, we were taking these logs of the file, and we were checking if there were some anomalies. For example, this was checking that usually every file is opening at some time, but if there is a file which is opening much longer, then we were able to pinpoint the problem and find it. Because this kind of anomalies, if there is more of them, then you end up really holding whole project, and it can end up that people at the morning waiting 40 minutes just to open and do something. And it can happen when you have automatic save, and again sometimes it could be very crazy with these softwares. This is again looking for sync times, finding whether this is what actually I was just saying. Checking whether these sync times are normal or something is not correct. And here we have a small video how we were able to check. This is not just file from Eurovea tower, but every file we were working at the time, and we've been able to check whether. If you click on some file, you see how many patterns it have compared to average number of patterns, how many, for example, views which are not sheet, many kind of parameters which we found could be holding up all the project. So we created this database or parameters which were worth to checking on. So that was actually last slide of our presentation of the process. So and this is a reality which we are very proud of, and I thank you very much for your attention. So if you have any questions, please.
Okay, I would like to ask maybe, usually in architectural studios there are also different people who are occupying on different level of drawing or even certain processes. And from my experience, they have different set of skills, and not everybody can treat Grasshopper or Dynamo and so on. I wanted to ask how you implemented this sort of like need of having skills into the process. If you were focusing somehow on interfaces, or everybody who uses the files or the scripts had to know them deeply, or how was this treated in your object?
What do you mean interfaces?
I mean, for example, when we use these sort of advanced tools, we try to somehow simplify to the certain level that everybody can use it, or to certain level where they are able, just by sort of documentation, prepare the file to the state that the guy who is occupying of the more sophisticated processes doesn't have to spend hours just to cleaning the model, for example.
Okay. I would say we have two kind of words in our studio. We have architects, and then we have engineers, or we have kind of architects who are using more common software like SketchUp and just quick ideas, and some enthusiasts which are using also Rhino and Grasshopper. And the same thing is going also with engineers or users of Revit. But I think the most advanced how we kind of solve it is really with the Revit, because our colleague he created also custom tool for Revit, which is like not icon but set of tools which you open, which is he installed it on every computer through the command line, which is really software which is updated regularly through what is GitHub, but or similar things. So everybody gets the latest tool or the most latest version automatically updated in whole firm. So even people who really don't care about this kind of things can have this latest tool automatically in the Revit. And we have many okay, I can stay with that. We have many kind of lectures explaining how to use those tools. They are recorded and they are on our wiki page. But it's still, this kind of process is dependent of every colleague, how he is disciplined to follow the rules which are set, and that's a very big part of our big managers to BIM managers to on and on explain the same things, and but it's actually that's the process which I believe is not like you do it once, but you have to do it constantly.
Thank you very much.
Thank you, very interesting. It's really amazing to see how it works. So my question really relates to the way you integrate engineering analysis tools. You did mention structural design, but there are other aspects to do with other aspects of engineering, like energy, like life cycle assessment. So really my question is, how do you integrate the work done by the engineers to the architectural work you do within Revit and the tools that revolve around Revit, and how do you synchronize the work that comes with this multidisciplinary team? Is that something you do, or do you have a one source of truth, which is the Revit model, and everyone works around the Revit model, and you control access to the different entities of the model, or do you work in a more linear way? So,
actually, this is really like looking back what we went through. And now we are very much aiming for one source of truth, but I would say we are not yet there, because it depends on how. But we're getting there. We're getting everything is based on the Revit. Now, actually, one source of truth is Dalux. Everybody is using it, even on the building site. Even the people who are very skeptical about it, then when they see it, how to use it, they love it. But we want to push it more. We have some ideas, and we aiming for it, so it will be more mistake proof.
Thank you for your lecture. It's very interesting how you managed to handle such a complexity. My question would be that, also I appreciate the way you managed to solve some of the problems in an automatic way, and it's a smart way of dealing with coordination of different sources of decisions. I've got a more general question. After you went through such a large project, and after you had to develop your own tools to simplify certain tasks, looking back, what tasks would you like to automate the most? Which are the pain points that you either have managed to automate or haven't managed to automate, but you would really like to automate those tasks so that you have more time on your hands to do something else? What is like the first thing that can be automated and have or haven't been automated yet? Thank you.
Okay, but I think this is more question for our head of BEAM department. Can you say so?
Môžeš to potom preložiť pre kolegov. Zásadné dve veci, koordinácia a dokumentácia. To je ako 85% času a peňazí strávených alebo zabitých na takýchto projektoch. Čiže koordinácia typu mať viac alebo dokázať viac automatizovať clash detection a náväzné veci na to. Tam sme sa učili veľa na tomto konkrétnom projekte, teraz sme už ďalej. A dokumentácia, to znamená, to je úplne najväčší pain point. Dokumentácia totiž, a tam máme riešené, ako zlomiť to myslenie ľudí, hlavne na stavbe, na úradoch, niečo, že v podstate výsledkom takto sofistikovaného modelu nemusí byť ten 2D výkres, v podstate, ktorý všetci potrebujú mať úplne rovnako okotovaný, ako keby ho kreslili v roku 1937. A to je časovo naša najväčšia investícia, splošťovať ten model na konci v podstate v tej dokumentácii, aby bol prečítateľný spätne aj z tej 2D dokumentácie. Toto, keby sa nám raz podarilo zvrátiť, tak máme vyhraté. Všetci.
Okay, I try to translate that 80% of our time it's for actually documentation and clash detection or automation. But actually, I would say that even the documentation right now is our biggest problem in terms of what others still want from the project. We have very sophisticated model already built where you can do sections and where you can find every detail you want, but people still want us to deliver the 2D paper documentation, which is just flatten down all the information model into this kind of partial information. So this is our kind of biggest task to pursue also contractors, client, that this shouldn't be the main end point of this paper documentation, but they should learn how to use the model.
I would maybe like to add on Jan's previous question. You have shown a lot of small tools that were somehow connected to the big environment of multiple softwares. As I understood, you developed them in-house for your very specific needs. When were you developing them? Did you consider them something that will be reused in the future for your next projects, or maybe it's just a small tool that will be thrown out, and in the future, maybe knowing what have you done, you will develop something similar and more advanced?
Yeah.
If I may add to that, in addition to that, not only tools but also data that you generated for this project, do you consider that data, geometry, whatever assets you are using, do you consider them reusable?
Okay, The first part was, I think, simple. The second one will be for you. The tools definitely they are not just for this project. They are reusable, and I would say they are made by our colleague who is very big enthusiast, and those tools are also available public because everybody can kind of have them through the GitHub, and so it's really a bigger thing, not just for the project and not just for us. So, but assets and geometry, I don't know. That's also a question for you.
Definitely not the geometry, but the parameter data, yes. Name of the parameters, the sum of the parameters, there's hundreds and hundreds of parameters. Yes.
Maybe can I have one? Yeah, one more, please. When we teach these parametric tools in school, we usually say that the great advantage is that you can make design decision right at the end of the whole process, and everything changes, and you get all the outputs actualized and on point. What's the reality? What is the workflow? Where are the milestones that once you go through, maybe it's the stage of documentation that you cannot go back to change the design or some detailing and stuff like that?
I can answer for my side. Maybe you can answer then, because it's. I think in certain way it is happening. Also after the part where many things is kind of decided and you cannot change everything again, but you still those tools are very helpful to grasp other complex problems which need to have a complex kind of complex answer. But so I would say it partially it still works. Like, but I know that the dream is to have like a tool that you can. And I hope that I could see it from your presentation, you know, but that grab kind of incorporate many stages together, and you can do at the beginning options and go through different stages and get informative answer. But in our reality, we do it partially with partial tools and partial problems. We have to kind of abstract the problem in order to be able to hold it.
Maybe I have another one. You mentioned that this documentation is a difficult problem, and we always see it in the permission process. But you mentioned also that it's not possible for every contractor to buy the software and be as sophisticated as you are in projection. And I wanted to ask, what do you think is the future, or what would be ideal state of this? If it would be like sort of simplification of model, or what would be the best solution to deal with the data without flattening them too much, but still not having not having to document it in the old-fashioned way or flattening to the plans.
Definitely, like what we said previously, the ideal state would be that the people who need it for construction side that would be able to use the model. I think that's the ideal state of our like construction environment. But from point of model, what going to change in terms of tools, I'm not so much. I envision that maybe Rado.
Zase iba prosím, prelož to potom, lebo toto nenaformulujem. Tá budúcnosť je možná už teraz, ako tie všetky nástroje máme k dispozícii a v podstate už len to, čo sa pohybuje v tejto BIM komunite, a to je jednoduché zdieľané dátové prostredie, ako ten common data environment je veľmi jednoduché riešenie na toto všetko. Pristupuje tam kdokoľvek, odkiaľkoľvek, bez nutnosti inštalácie akéhokoľvek softvéru a má prístup vlastne k kompletnej dokumentácii aj k modelu. Na tomto projekte, ale na týchto projektoch používame riešenie firmy Dalux, ktoré je pre nás úplne zázračné, ako poviem praktický príklad, tento model má asi 4,5 GB, v Daluxe má asi 140 MB. Sú tam jednak jedné tie isté dáta, to znamená, že označí sa hociaký prvok, vidí všetky parametre, ide na hociaký výkres a tak ďalej a tak ďalej. To znamená, že to, že sa to používa alebo nepoužíva na stavbe, je vec nás, ako presvedčiť, a to, že sa to používa, môže alebo nemusí používať na úradoch, je vec, ako donútiť tomu ten štát, alebo ten štát, aby donútil tých úradníkov, ale je to, netreba žiadnu nejakú že spektakulárnu technológiu na to, je to možné už teraz. A keď sa to povedal, že od zajtra to robte iba takto, je to možné.
Okay, I just translate that the ideal kind of state is already possible. We have already tools that we could use and could be very helpful for that. They call common data environment, which create environment for everybody to be accessible, everybody to find certain data without need of buying expensive software. For example, at our scenario, we used Dalux, which transfer our whole BIM model, which in Revit has 4.5 gigabytes, into model which has 100 megabytes at Dalux, and is still one-to-one in terms of which information you can find there. You can in 3D go everywhere, you can see all the information there. Now, actually, there was the last thing that Dalux is very kind of helpful at construction site. People intuitively are using it. As I mentioned previously, but now it's a big challenge how to pursue people. I don't know at the what is that process of permission process? I don't know whether it's the right word, but through this legal processes to be like. To be enough information for them to use the model or to use this common data environment and not to ask for those paper drawings.
My question, at first actually I would like to thank you, Jan, Martin and all your team that you create a presentation that I think we recorded it, and I try to really persuade all the students at the school to watch it, to understand why this competition and to use many different tools is important to learn here, and it's possible still. My question actually is aiming on this creative part that you are using, for example, Rhino, and have you find, or you didn't actually completely explain how you move from the Rhino to the Revit. Where are the cavities, or when it's the Rhino brings something positive, and when it starts to be too restrictive or slowing things down?
Okay, Yeah, actually, I said that we structured the presentation like that we're not going to speak so much about that because we're going to focus on this. We understood that this is what was wanted from us. But if I can answer that, most of our designers using these conventional tools, but we pursue or push more for the Rhino and parametric softwares, and I would say quite few of them, they use it very like I don't know the right word, but in this parametric state, they are not building the model like copying, pasting, and cutting, but defining definitions in Grasshopper and testing many options. This is our kind of main workflow with these parametric tools to test the options very quickly. If we use it for this.
So actually it's kind of the design process is computational. So we program it in the Grasshopper and that creates the design.
But not like a very abstract one, but instead of kind of drawing the wall, to define it a set of parameters so we can check different dimensions and different options.
Mm-hmm. So going completely paperless is probably the aim. Nice, yeah. Thank you.
Okay, thank you.